Okay, greetings, learners. We're going to continue with our paper 2. Remember, last time we finished with question 3 and 4, and we even managed to take question 5. So now we're going to take question 6. Question 6 is saying, in the diagram, the graph of f of x is equal to 2 sine 2x, and g of x is negative cosine x plus 45 degrees, are drawn for the interval. They have given the interval as you're going to see it. X is a member from 0 degree to 180, and point A is 105 degrees, negative 1 lies on F. All right, so when you watch your diagram, you will see that we're having these two functions, f of x and g of x. Now, the first question is a 6-1. 6-1, the question is, write down the period of f. To get the period of f, we're going to consider period of f. We're going to consider our function f of x is 2 sine 2x. So we will take this 2, and we're going to take 360 degrees divided by 2, and our period will be 180 degrees. That is the first question. The second question is 6-2. Determine the range of g in the interval. X is a member of this interval from 0. When you check on the graph, is from 0 to 180 degrees. So if we watch very well, we can see that the range will be range of g is going to be, when we watch very well our diagram, you will see that g of x is equal to negative cosine x plus 45 degrees. If we replace x by 0, it will be negative cosine of 45 degrees. And the negative cosine of 45 degrees is going to be square root of 2 over 2. So if you check with your calculator that cosine of 45 is square root of 2 over 2, as we are having a negative, replacing x by 0 is going to be negative square root of 2 over 2. So here we're going to consider y, because we are talking about the range. So it will be y will be a member of this interval, negative square root of 2 over 2. And if you watch very well the graph of g, the maximum is 1. So is from negative square root of 2 over 2 to 1. This is the range of g in the interval of from 0 to 180 degrees. From there, we're going to question 6-3. Question 6-3 is saying, determine the value of x in the same interval from 0 to 180, as you can see it on the diagram, for which 631 f of x times g of x is greater than 0, meaning where these two functions are intersecting. So you can see it from the diagram. It's from 45 degrees to 90 degrees. That way, this product is positive. So then we're going to write that x is a member of so we see it from our diagram, 45 degrees to 90 degrees. This is where the product of these two functions is positive, strictly positive. The next question is going to be 632. There we're having f of x plus 1 is less than or equal to 0. So this is an inequality. We're going to solve for f of x will be less than -1. So if you watch very well on our diagram, f of x is less than -1. We can see it. It's less than or equal. So what will be the value of x? The value of x will be writing them like this. X is a member ever. Then you can see the first angle is 105 from the diagram. And from 105 degrees to 135 degrees, the difference is 30 degrees. So if we take 135 plus 30, we're going to get 165. So the other value is 155. So f of x will be less than or equal to -1 in this interval, going from 105 degrees to 165. This is the part of the function which is under -1. If you watch it from the graph, it's like that. So then we have covered the first three questions. We're going to clean the board so that we can continue with the rest, because we're having 6-4 and 6-5 remaining, so that we can cover this question 6. Let's clean the board. Okay, so we're taking question 6.4. Another graph P is defined as P of x is equal to minus f of x, and we're having a point D. The coordinate of D is k, -1, lies on P. So this is another graph P, defined as P of x is equal to negative f of x, and the point D is on P, on this other graph. So the question is, determine the value of k in the interval x is a member of this closed interval from 0 degree to 180 degrees. So our f of x is 2 sine 2x. The other graph is going to be minus f of x, so we're going to have here negative, and it's going to be equal to the second coordinate of a point D, so it's going to be is equal to -1. -2 sine 2x is equal to -1. It will be 2 sine 2x is equal to 1, and sine 2x will be equal to 1/2. So here we're having a trigonometric equation to solve. Sine 2x is equal to 1/2. So here we're going to consider the solution of sine alpha is equal to sine beta. Then alpha will be equal to beta plus 2k. If we consider the general solution of a trigonometric equation for sine. So sine of an angle being equal to 1/2 is 30 degrees. So we'll be taking 2x is equal to 30 degrees, and the first value of x will be 15 degrees. The second value that is going to be in the second quadrant, the sine of 150 will give us 1/2. So we will consider 2x is equal to 150, and then the value of x will be 150 divided by 2. The second value will be 75 degrees. Because if we take 75 times 2, think we're getting 75 times 2. We're getting 150, so it's correct. So the values of k in the interval given will be 15 degrees or 75 degrees. So here's the answer for question 6.4. The last question is the 6.5. What are they saying? Graph H is obtained when G is translated 45 degrees to the left. Determine the equation of H. Write your answer in its simplest form. 6.5. Here they're talking about a new graph. H is obtained when G is translated 45 degrees to the left. So we gonna start by G of X is equal to negative cosine X plus 45 degrees. So what will be our H? And remember, when we go to our courses, when they are saying that G is translated 45 degrees to the left, we're going to add to this angle 45. And our new function will be minus cosine X plus 45. Translated to the left, we add 45 degrees. So H of X will be equal to negative cosine X plus 90 degrees. And according to the reduction formula, minus cosine X plus 90 is going to be equal to sine X. So H of X is equal to sine X. So the equation of H written in its simplest form is H of X is equal to sine X. So we have practically covered question 6. I'm going to clean the board and then we will go to the next question. And this is still dealing with trigonometry before we start Euclidean geometry, the last 3 questions. So I'm going to clean the board and then we will take question 7. Good, so now we're going to question 7. This will cover practically the part of trigonometry. Here's the question. In the diagram, ST and K lie in the same horizontal plane. RS is a vertical tower, as you can see on the diagram. The angle of depression from R to K is beta. TSK's angle alpha, you can see it at the bottom, and TS is equal to P. This is one of the sides of the triangle on the floor, and P meters, and the area of the triangle STK is Q square meter. So let's write what we are given before we take question 7.1. We are having that the angle of depression from R to K is angle beta. And then we're having another angle. This is a TSK. This angle will be equal alpha. And TS is one of the sides of the triangle on the horizontal plane. TS is equal to P meters, and the area of the triangle STK. Triangle STK area. Let's write area of triangle STK is equal to Q, and the unit is a square meter. So from this information, we're going to question 7.1 now. Determine the length of SK in terms of P, Q, and alpha. So here I'm going to remind you something when dealing with the area of a triangle. In grade 11, we have talked about the area of a triangle. Let's consider a triangle A, B, C. This side will be a small a, the other side is B, and the other side is C. If we want to get the area of a triangle ABC, is going to be equal to 1 over 2 AB, we multiply by sin C, meaning half of the product of these two sides, A times B, and the angle between the two sides. So, if you are not quite sure, you can go and check your formula sheet, because it's the last page information sheet. Then you will see that area of the triangle ABC is half A times B times sin C. So this is the formula we're going to use here now. Here we are dealing with a triangle STK. Applying this formula here, we're going to write area of a triangle STK. Q will be equal to 1 over 2, and the two sides which are taking angle alpha is a P, and the other side is SK. And then we're going to multiply by the sine between these two sides, TS and SK. That is angle alpha. So I've directly replaced the area of the triangle STK by Q square meter, because this was given. So the question is determine the length of SK in terms of P, Q, and alpha. As you can see it from here, we're just going to cross multiply. We'll be having 2Q is equal to P SK times the sine alpha. And our SK will be equal to 2Q over P sine alpha. Then we got the answer for the first question. SK will be equal to 2Q P sine alpha. So it's so easy if you know how to use your formula. If you're having any question, make sure you ask, and I'll be able to respond and help you. So we're going to the next question. Is question 7.2. I'm gonna need this space. Let me just clean this fast. Then we're going to continue with question 7.2. Question 7.2, they are saying, show that RS will be equal to 2Q tangent beta over P sine alpha. So you see now, we have already found the formula for SK where Q and alpha and P are used as they were saying it in the question, the previous question 7.1. Now in this question 7.2, we are having a new element, is beta, angle beta. So watching our graph, they said that the angle of depression from R to K is angle beta. So as we are seeing a tangent beta here, this angle, talking about corresponding angles or alternate angles, angle beta will be down here where we're having our point K. So if I want to get tangent beta, it will be equal to opposite side. The opposite side is RS, and the adjacent side is SK. This is tangent beta. So tangent beta is RS over SK. The question here is to show that RS is equal to this. If we consider this tangent beta, by cross multiplying, we'll write that SK, RS will be equal to SK multiplied by tangent beta. I think this is quite easy to understand. Once you know how to get the tangent beta, opposite side over adjacent in a right angle triangle, it's easy now to cross multiply, and then our RS will be equal to SK. We got it already. SK is a 2Q over P sine alpha. We're only going to multiply by tangent beta, and then we're going to have the response of this second question. So RS will be equal to SK, here is our SK, 2Q over P sine alpha multiplied by tangent beta. And then we are done. We have shown that RS is equal to 2Q tangent beta over P sine alpha. I'm just going to clean the board, and then we will take the last question covering this question 7. Okay, so we're taking the last question of question 7. That is going to be 7.3. Calculate the size of alpha if alpha is less than 90 degrees. So our alpha, and they are saying that alpha is less than 90 degrees. They have given us the value of RS is 70 meter. The value of P is 80 meter. And the value of Q, the area of a triangle STK, is given by 2,500 square meter. And the value of beta is also given 42 degrees. So now the question is to get the size of alpha. If we want to get the size of alpha, we will take our RS, the answer from question 7.2 is still on the board. RS is equal to 2Q times tangent B over P sine alpha. So if I'm going to cross multiply here, I'll be having P RS sine alpha. This will be equal to 2Q tangent beta. And the sine alpha will be equal to 2Q tangent beta over RS times P. So when we will replace all of these values given, RS is given, P is given, Q is given, and beta is given. So we're just going to replace. So this is what I'm going to write. Sine alpha will be equal to 2 times Q, 2 multiplied by 2,500 multiplied by tangent beta. Beta is given by 42 degrees. The value of RS is 70, and the value of P is 80. Now, if you want to get your alpha, we're going to take the inverse of sine alpha, meaning arc sine alpha, and then we'll be having that our alpha will be equal to sine minus 1 of this value here. Then we will need our calculator. We're going to take arc sine on our calculator of this value, 2 times 2,500 multiplied by tangent 42 degrees over 70 times 80. So let's use the calculator and see what will be the value of angle alpha. Using my calculator, 2 multiplied by 2,500 multiplied by tangent 42 degrees, and over 70 multiplied by 80. And then I'm going to press equal. Let me start afresh, because remember we are having sine alpha is equal to this value. If we want to get alpha, we will take sine minus 1 on the calculator, meaning the inverse of sine. So this is what I'm pressing now. Shift to sine. We're doing this calculation. So 2 times 2,500 multiplied by tangent 42 over 70 multiplied by 80, and then we're closing the bracket. When I press my calculator, here's the value. The calculator is giving me 53,5725,593. So we're going to round off this value to 2 decimal places. So our alpha will be 53, 51 degrees. So it's quite simple. The only thing you are doing is, after replacing all of these values in sine alpha, to get the value of alpha, you use your calculator and you press shift sign. The inverse of sine is arc sine, and you put all of these values. The calculator will give you the final answer I'm having here, and rounding it off to 2 decimal places, it's going to be 53,51 degrees. Then we are done with this part of trigonometry, question 6 and 7. So we will continue with the part of Euclidean geometry. Thanks for watching. Don't forget to subscribe, like, comment, and share the video if you learned something. Thank you.